going to put this one right there. So this one's going to be on the test. There will be a question like this on the test. Okay? So as long as you can find these key features, like we just went over, you should do fine on this one. Okay, I am going to take a few minutes to go over questions on your homework assignments. So, hey, when you're going over the review, if you want to skip this part, you can. I'm going to record it for those students who are not here, so in case they want to go back and look at some of those things. There were a couple of problems on 2.5 that some of you guys didn't know how to do, and I want to review those first. So questions on 2.5. What were some of them? 25. What does 25 say? Do it to me, Caitlin. Okay, so give me one row. Which row do you want to give me? The middle row. What was the first one? Minus 12x plus 36. What's the next one? Minus what? And what's the third one? Plus what? Okay, so it wants to know, question 25 wants to know if any of those three rows above it of problems, it wants to know why, if the coefficients of the first and last term are basically the same. It says basically because, like, this is a positive 36 and this is a negative 36, right? So why are they basically the same thing? Why are the middle terms different? Yeah. For instance, right here, I don't know if you guys could hear Shaden right there, but like the factors of 36 that can times together and get 36, but multiply together and get negative 12, which is the middle term, are negative 6 and negative 6. Whereas if you look at the end one over here, you also have a positive 36 for the end, right? But two numbers you can times together, but they have to add up to negative 15. Well, negative 6 and negative 6 don't work, right? Because they add up to negative 12. Okay, negative 12 times negative 3, because negative 3 times negative 12 is still 36, but they add up to negative 15. And so you have to find the numbers that multiply to get the last number and add to get the middle number. And so sometimes those are different numbers. There's more factors of 36 than just 6 times 6, right? 12 times 3, and so forth. Now, what about this one right here, the middle one? It doesn't even have a middle term. It's 0. It actually has a middle term. It's just 0. So they have to add up to that. Well, how do you do that? Yeah, and since this is a negative 36, we know that one of these has to be negative, one has to be positive, so that when we multiply, like x minus 6 times x plus 6, see, let's write these down. This one was x minus 6 and x minus 6. And this one was x minus 12 and x minus 3. Okay? When you multiply this one out, you're going to get negative 6x and positive 6x for your middle terms, which are going to add up to 0, right? And so that's why there's not a middle term there. So the answer to that is because even though you find factors of 36, you have to find the factors that add up to the middle term, which can be different. Does that make sense? Okay, that was the answer to 25. Is there another question you guys would like to ask about? You guys, I'm going to skip right to here then. One of the review questions I'm going to ask you today is actually two questions. It asks you to write an example of a quadratic that is a difference of two squares. Write it both in standard form and factored form. And then part B was write an example of a quadratic that is a perfect square trinomial. Write it in both standard form and factored form. Raise your hand if you feel like you know the difference between those two things. Brianne does, because I went over it with her last night. It sounds like we don't understand this very well. Shaden, you got it? A couple of you guys got it back there? These two questions right here. What is a difference of two squares? What is a perfect square trinomial? Okay. Yes. Okay. So Shaden said that a perfect square trinomial has the same factors in it. I'm going to give you an example of that. Everybody, take a minute. Factor that down. I want everybody to do it yourself so you can think about this. What two numbers can I times together and get 9? Add together and get 6. Okay, so what are my two binomial factors going to be? X plus 3 and x plus 3. By the way, the factors are 3, right? 3 times 3? But the binomial factors would be x plus 3 and x plus 3. You guys all remember what a binomial is? It has two terms. So x plus 3 is binomial. The other x plus 3 is binomial. What's the short way of writing this? Okay, this can be written as x plus 3 quantity squared, right? Okay, now, x squared plus 6x plus 9 is known as a perfect square trinomial because when you factor it, both factors are exactly the same. Do you understand now what a binomial, what a perfect square trinomial is? Yes. Well, yeah, a perfect square trinomial, you're going to have it in vertex form because you could write it as y. If this was a y equals, this written as equation, y equals x plus 3 squared, and you don't have to put this, but plus 0. It's in vertex form is what you're saying, right? Where's the vertex? -3, 0, right? So the vertex is at -3, 0. So yeah, it technically, you can put anything in vertex form though. Any of the quadratics in vertex form. But yeah, that one's already a perfect square trinomial, so it makes it easy to put it in vertex form. Makes it easier. Okay, what's a difference of two squares? Raise your hand if you know that. Shaden, you're on a roll. Go for it. Okay, give me an example. X plus 3 and what? Not x minus 2. Yeah. The numbers are the same, but the signs are different in between, right? If I multiply these together, I get x squared plus 3x minus 3x minus 9. What happens to the middle two terms, you guys? They cancel. They add up to 0, right? So I get x squared minus 9. This is known as a difference of two squares, and it is a binomial because it has two terms. But it's called a difference of two squares. Why do they call it difference? Where does the word difference come from? Yeah, well, actually, it's because this form right here, that's a minus sign is a difference, isn't it? That's a difference. And what do we mean by two squares? Yeah. X squared is a perfect square, isn't it? What's the square root of x squared? X. And what's the square root of 9? 3. Those are perfect squares. So a difference of two squares means that the first number is a perfect square, the second number is a perfect square, and there's a minus sign in between them. And they always factor to be the same factors except for the signs are going to be different. Do we understand that? All that this helps you do, you guys, because really you guys know how to multiply x plus 3 times x minus 3. Okay, but it helps you to recognize, it helps you with recognition, and you'll be able to do problems faster if you know these things. So you're gonna come upon these two things so much in your math classes in the future that if you can recognize them, it'll save you a lot of time. So that's why you wanna know these. Okay, time is money sometimes. Okay, all right. Now, is there another question you guys wanted to ask about on that? So what are some of the what are some things that are same about these two things, you guys? Okay, they both have x squared, so they're both quadratics. What else is the same? Say it again, Brendan. Oh, I thought you were raising your hand. Okay, what else, Jake? C? Okay, they both got the same C, kind of. This one's a positive 9, that's a negative 9, right? Yeah, they can be opposites, though, right? They're both x squareds. What's different about them? Okay, this one's not going to have a B. This one's going to have, this one's going to be, half of it squared is going to be that number, right? But what did you say, Alyssa? Yeah, I think that's the biggest difference you guys need to recognize. This one has the same signs, right? Where this one has opposite signs. Justine? Okay. Any other comments or questions? Okay, so when it says to write down some of the differences and things like that, and what's the same, what's different, those are some of the things you can write down. Okay, other questions on the assignment? 23, okay. Let me go back up here. 23. What does it say? Minus 2x? Minus what? Okay. I don't, we did some of these on the assignment and with our tasks that we were doing, you guys, but I don't think we have done enough of these just practice. So I want to go over one of these with you and make sure you understand it. I was actually going to go a couple of these with you today, so this will be one that's on your homework. What we're going to do is we're going to list all the pairs of factors for 15. What are all the pairs of factors of 15? 3 times 5, what else? 1 times 15. Anything else? Say that again. Okay, and we could write -3 and -5 because -3 times -5 is a positive 15 and -1 times -15 is a positive 15. But whenever the leading coefficient is positive like that, we don't worry about doing the negatives. We always just do the positives. It will make it easier to factor, okay? So we're just going to write the positive ones of this one. Now on the end one, if you can write them either both negatives or both positives, you have to list them all, okay? So now we got to go down to the end one. What's all the factors of -8, pairs of factors? -4 and +2. What else? Okay, so +4 and -2. -8 and +1. And 8 and -1. Okay, anything else? Now what we have to do right here, guys, really all these problems come down to is multiplication and addition. You just got to find the right combination. So if I'm looking right here, I'm trying to find what pair over here is it going to be 1 and 15 or 3 and 5. Am I going to times by which pair over here so that when I add their numbers together, I get a -2. Okay, now if I'm looking at this, I need these numbers to be fairly close together. I can actually see what it's going to be. If I times 5 times +2, you guys, what's 5 times 2? 10. And if I times 3 times -4, what do you get? What happens when you add 10 and -12? You get a -2. Well, that's what my middle term is, right? That's what I'm trying to find, is I'm trying to find the two pairs that when I multiply them together and then add them, I get the middle term. It's -2. So I now know my two pairs. It's 3 and 5 and -4 and +2. So I don't need the rest of these. Okay, I just need those two pairs. And so I'm going to write my two binomial factors. Can I erase this part right here? One of my binomial factors is, I'm going to write the 3x and the 5x. Remember, the 3 and 5, these are the coefficients for the x. Because when I multiply 3x times 5x, I get 15x squared, right? Okay, now my last two numbers are going to be -4 and 2. Now it matters which order they go in. It matters which one goes with the 3 and which one goes with the 5. Let me ask you guys this. When you're doing the FOIL method, is that what you guys learned it by? FOIL? When you're FOILing, do you ever times a number in a binomial by the other number in the binomial? In the same binomial? No, you never do. So if I have to times 3 by -4 to get what I want, so where does -4 have to go? Yeah, it has to go over here away from the 3, which leaves me with +2 being times by the 5, and the only way that can happen is if it's in the opposite of the 5. There's my two binomial factors, and I've got it factored. Now, how can you check to see if you did it right? Yeah, multiply them back together, right? I could go 3x times 5x is 15x squared. 3x times negative 4 is a negative 12x. 2 times 5x is a positive 10x. 2 times negative 4 is a negative 8. I combine the two middle terms right here, and I get negative 2x. So I have 15x squared minus 2x minus 8. Is that what we started with? Then I did it right. So here's my answer. 3x plus 2 times 5x minus 4. And I've got it. And I've got those factored. We're going to practice a couple more of those today. So you guys can look at that. All right. I am going to answer a few questions on 2.6. Okay. Are there some questions on 2.6? Or would you guys like some more time in as a group to work on these? Okay, this is what I want to do. Everybody get out to 2.6 right now. I am going to let you guys talk to each other about some of these problems and explain it to them. I'm going to give you guys about 10 minutes right now to do that, okay? Then I'll come back and answer a few questions before we do the review. All right. Number 5 on lesson 2.6 assignment gives you the factored form right over here. I put FF for factored form, VF for vertex form, and SF for standard form. You're supposed to find the other two forms. Well, standard form is easy because what do you do to find standard form? Okay, you're going to multiply them together. So I go x times x is x squared. X times negative 3 is negative 3x. 5 times x is 5x. 5 times negative 3 is negative 15. Add the two middle terms together, and that gives me x squared, y equals x squared. By the way, these are equations, not just expressions. So make sure you put the y equals on there. Okay. Negative 3x plus 5x is 2x minus 15. So we have standard form. Okay. Now, vertex form, you have to complete the square. Okay. So pay attention to this. Remember, complete the square. We did a lot with this a little while ago, but I think you guys have forgotten it. Okay. What we're going to do is we're going to take and we're going to group the first two terms, the x squared plus 2x. So I'm going to write x squared plus 2x plus, and I'm going to leave a space because that number right there is going to be my number that completes the square, right? And the negative 15, I still have that, so I put it on out here. What number goes in there to complete the square? Raise your hand if you remember. I just want to see. Don't say it out loud, but just remember. If you remember how to complete the square, you guys are all going to remember as soon as I tell you. What is it, you guys? Okay, it's 1. And how do you get that? Take half of the x term. What's half of 2? 1, and then you square it. And squared is 1. That's how you get that number. Do you remember doing that? Okay, so we complete the square by taking half that number and squaring it. Now, I just added a 1 to the right side of this equation. So all of a sudden my scale, my balance scale goes like this because I added 1 to that side. So what do I have to do? I could subtract it from the left side. I mean, I could add it to the left side, or I could subtract it also. So minus, right? Do you remember doing that? Okay, now, here's what we were practicing today. Remember perfect square trinomials? What is a perfect square trinomial again? We just talked about it. When the two factors are the same. By the way, what two numbers can you times together and get 1 so that when you add together they get 2? 1 times 1. So what are my factors? X plus 1 and x plus 1. And what's negative 15 minus 1? Negative 16. Are we done? No, because what's the short way of writing x plus 1 times x plus 1? x plus 1 quantity squared. That is how you complete the square. So now I have vertex form. Y equals x plus 1 quantity squared minus 16 is vertex form. Okay, now this problem wants you to do what next? Okay, show the vertex and at least 2 other points. Okay, so can I erase this part, or do you guys want, should I keep that part? We'll just do this. Okay, I am going to graph this. Okay, so I have the vertex. What is the vertex? Negative 1 and negative 16 is the vertex. Yep. Thank you, Kayla. Okay, so negative 1 comma negative 16 is my vertex because I have vertex form that shows me the vertex. So I'm going to go to negative 1. By the way, on my x scale, I'm going to go in ones. So this is negative 5 and this is positive 5. But on my y scale, I am going to go in 2. So this is negative 16. So I'm going to go negative 1 comma negative 16. I'm going to use a different color. That would be this point right here. Okay, so there's 1 point on my graph. And if I was making an XY table, negative 1, negative 16 would be my first point. What is another point? I actually can get a couple different points using all my different forms. I can get my x-intercepts. How can I do that, Christian? Yeah. What you think about this? What do I put in for x and add 5 and get 0? Negative 5. So one of my x-intercepts is negative 5, and the other one is positive 3. So I'm going to go to negative 5, comma 0, which is right here, and 3, comma 0, which is right here. And that is 2 more points. So I have negative 5, comma 0, and 3, comma 0. Is there another point that one of these other forms will give me? My standard form, I can get my y-intercept, can't I? Remember, the y-intercept's always the constant, because if you put 0 in for x right here, you're going to get 0 squared plus 2 times 0 is all 0 minus 15. So 0, comma, negative 15 is another point. 0, comma, negative 15 would be right here. By the way, if I used my axis of symmetry and reflected this point over, I could get another point. Yeah, negative 2, comma, negative 15. So there's 5 different points. It only wanted us to get how many points? 2. So now I can draw my graph. Oh, it said 2 on each side of the vertex? Okay, so it wants us to get 5 points. Okay, there's our 5 points right there, right? Because remember the axis of symmetry reflects points over? We had 0, comma, negative 15. So if it's over 1 unit, if this is over 1 unit from the axis of symmetry, right? 0 is 1 unit away from negative 1. So if I go the opposite way to negative 2, comma, negative 15, that will be another point. Does that help you? Okay. So now I have all 5 points. Now, part of that thing says to, can I borrow this, Mackenzie? Because part of your problem says down at the bottom, says show the first differences and the second differences. Don't worry about that. Remember, that's from module 1. And I want you to see that on the quadratic equation, the second differences are the same. But in order to do that, you would have to list a lot more points, because you'd have to list consecutive points. I don't want to take the time to do that right now. So don't worry about that part. Okay? So this is how you do problem number 5. Okay, I'm going to do number 8 right here with you. Okay? Now, on number 8, you guys, you have a graph. Now, looking at this graph, which one Which one of these would be easiest to get? Standard form, vertex form, or factored form? Because why? Because I have the two x-intercepts. What are they? -3 and -2. So factored form would be what? X plus 3 and x plus 2. Okay? Hey, you guys, I'm talking right now. Okay? If you guys have questions or something, but otherwise listen. Yes? Oh, and it crosses at 3. So we've got to take that into account as well. Okay? Probably because it's probably going to be 1/2. Okay, so we have to times it by 1/2. This is kind of a tough one. How many of you did that? If you're not working on it because you thought you had it already, you might want to go back and look. Because Shaden was pointing out that our constant would be 3 times 2, which is 6. But if you look, this thing crosses at 3. So how do you get half of 6? I mean, how do you get 6 to be 3? You divide it by 2 or times it by 1/2. So that's why we know it's 1/2 right here. Okay? So you had to times it by 1/2, so we can erase this part right here. Okay, so we now know that factored form is x plus 3 times x plus 2, and then times it by 1/2. Okay, now standard form we get by multiplying these together. Well, I'm going to get 1/2 times x squared plus 5x plus 6 if I multiply it out, right? And if I multiply that by 1/2, I get x squared over 2 plus 5/2 x plus 3. So there's my standard form. Y equals x squared divided by 2 plus 5/2 x plus 3. Do you guys understand how we got that? Multiply x plus 3 times x plus 2. This is what you get, right? And then since we had a coefficient of 1/2, you times each thing by 1/2. 1/2 of x squared is x squared over 2. 1/2 times 5x is 5/2 times x. And 1/2 times 6 is 3. -5 over 2? No. Okay, that's standard form. Oh, vertex form is going to be really fun with this one now. Okay, it is possible. Okay, this is how you do vertex form. Okay, we're going to have to group the first two terms. X squared over 2 plus 5/2 x plus, leave a gap, and then plus the 3, right? Remember, in completing the square, we got to complete the square. Here's the problem. You guys, we have a 1/2 right there. We don't like to have fractions. What we're going to do is we're going to factor a 1/2 out of this. So we're going to have 1/2 times x squared plus 5x plus the blank plus 3. So anytime you have, in fact, anytime you have a factor, your leading coefficient of x squared is something other than 1, which in this case it's 1/2. You got to factor out whatever that number is out of those first two terms. Yes, Stevenson. Branson. You got it? Okay. All we're doing is taking a 1/2 out so that we have a coefficient of 1 in front of the x. Okay. Now, to get the perfect square, how do I do that? Divide it by 2 and square it. What's half of 5? Leave it as a fraction, 5/2, right? Just, if it's an odd number, just put a 2 under it. 5 divided by 2, right? Square that. What's 5 squared? What's 2 squared? 25/4. So 25/4. Now, 25/4 is the same thing as 6.25 or 6 1/4. If you really want to use 25 divided by 4 is 6.25. Okay. So if you really need to, you guys on that, if you really need to, then I would If you really need to, change it to a decimal, but I think it's easier actually with fractions. Okay, now I just added 25/4. Actually, I didn't just add 25/4. I added 1/2 times 25/4. This is something new. I added this 25/4. I can't just minus 25/4 out here. I have to multiply 1/2 times 25/4. So what's 1/2 times 25/4, you guys? Okay, it's going to be 25/8. That's what I have to minus out here. 25/8. Got it? Because that's really, because anything inside of here has to be times by the 1/2. So when I put a 25/4, that was really a 1/2 times 25/4. So that's what I have to minus out here. Okay? Now, I'm ready to write this in vertex form. 1/2. I already know that this is a perfect square trinomial. What are my two binomials going to be? X plus what? What's the square root of 25/4, you guys? 5/2. That's what it's going to be. Plus 3 minus 25/8. What is that? Well, if 25/8 is the same thing as 3 1/8, right? So it's really 3 minus 3 1/8. So what if minus 1/8? So that right there is vertex form. So where's my vertex? Let's write this as a decimal. What's 5/2? That's going to be negative 5/2, which is a negative 2.5, comma, .125, right? Negative 0.125.
Oh, I had that.
There's my vertex right there. You guys notice when we went over there, we went over to negative 2.5 and we just went down an 8. Okay? So it was really small number you go down. So there we go. We're already given the graph. Yes. Well, remember my vertex is the opposite of this sign. It's going to be a negative 5/2. What's 5 divided by 2? 2.5. So it's going to be a negative 2.5. It's negative 0.125. If you go 1 divided by 8 in your calculator, go 1 divided by 8 in your calculator. Change it to a decimal. Okay. And that's how we got that. Okay? I know that's kind of a tough problem. And guess what? On your test, I'm going to put on the test, I'm going to put a problem like this for a bonus problem. How's that? I gotta see who can do this. Let's have a vote on this. How many of you want to do it as a regular problem? Christian. There's about 4 or 5 of you guys I think could do this. And a little practice and all of you guys could do this. Okay.